Going back to the first page, we have now gone over functions defined by a set of ordered pairs, by a table, and by a graph. By a graph was our visual way to be able to find the domain and the range by visually looking at my graph. The next type we're going to do is an equation. And an equation, we now should just be able to find the domain given the equation of our function. And we can do that by knowing our two commandments of mathematical domain. So pause the video if you need to write this down. But your first mathematical commandment is thou shalt not divide by 0. And if you put this in your calculator, if you do any number, 7 divided by 0, you get an error. And why is that an error? Because you divided by 0. You cannot do that. Okay, so thou shalt not divide by 0. The second one is thou shalt not take a square root or any even root of a negative number. Okay, now, mainly what we need to focus on is the square root, but I do want it to be known any even root. So the 4th root, the 6th root, the 8th, the 10th root, any even root you cannot. If it's an odd root, the cubic root, the 5th root, the 7th root, so on, that's fine to have a negative. But when we have an even root, including square roots, you cannot have a negative under it. So for example, if I do the square root of 25, that's fine. That's 5. But if I take the square root of negative 25, we get another error. Why? Because we have a non-real answer here. When you have a negative under that radical, you end up getting an imaginary answer. So you cannot take a square root with a negative underneath. So let's use these two mathematical commandments to find the rest of these domains. It doesn't ask for range here, just the domain. So in part A, if I have f of x equals 5x plus 11 over x minus 5, all I care about is that I don't divide by 0. So I'm going to take what's in this denominator, and I know that it cannot equal, so it's an equal with a slash through it. I know that it cannot equal 0. So solve this equation. We'll add our 5 over, and we get that x cannot equal 5. Now, I'm pretty sure in my math lab, for when you're doing your homework, you need to write this in interval notation. So if 5 is the only number on that number line that it cannot equal, that means it can equal any number less than 5. So that's negative infinity to 5 with a parenthesis. And then the union, it can equal any number greater than 5. So 5 to infinity. Okay, notice my infinities, these always get parentheses. My 5 here has parentheses, meaning it's not included. So this one will go all the way up to like 4.9999999. This one will start at 5.00000001, but it skips over the one number of 5 because it's not in brackets. And then you'll put the U in between for the union when you have two different sections here. Okay, let's try again on B. Same thing, the 7x, I don't care about because I don't need to worry about dividing anything by 0. There's nothing in the denominator. And I don't need to worry about taking the square root of the negative number because there's no square root. So then I come over here to this term, and what I need to worry about is, again, this denominator. I want to make sure that 2x plus 22 does not equal 0. So first thing we'll do is subtract that 22 over to the other side. And I get 2x cannot equal negative 22. Now divide by 2. And we get that x cannot equal negative 11. So how do I write that in interval notation? We need to talk about every number less than negative 11. So it's negative 11 or sorry, negative infinity to negative 11. Every number less than. Then the union, now we need to talk about every number greater than. So negative 11 to positive infinity. And these are really, really easy to check. Let's go back to this one. If you plug in 5, 5 minus 5 gives me 0. So that would make me divide by 0. Here, if we plug in negative 11, 2 times negative 11 is negative 22, plus 22 is 0. So both of those, if my x equaled 5 and negative 11, we would be dividing by 0. Now, starting with C, now we need the second one here. Because I have a radical, I know that I cannot take the square root of a negative number. We can take the square root of 0, though. That's going to give me 0. That one's okay. So we'll take what's underneath that radical and set it to be greater than or equal to 0. So add your 4 over. And we get x must be greater than or equal to 4. So in interval notation, that means we're starting at 4, and because it's greater than or equal to, it's going to have a bracket, to infinity. Okay, so if you go out of this solution set, if we go to 3, I have the square root of 3 minus 4, that's going to give me a non-real answer. So all of my input values have to be 4 or higher to work. Okay, D, almost the exact same. Take what's underneath that radical, x plus 12. And I know I can't take the square root of a negative, so it must be greater than or equal to 0. So subtract your 12. And we get x must be greater than or equal to negative 12. So we'll start at negative 12, and again, a bracket because it's greater than or equal to, so this negative 12 is included. And it will go to infinity. Now for E and F, we're just going to do both of these together as one. I have 2 mathematical commandments. Thou shalt not divide by 0. I don't have to worry about dividing by 0 here because I have nothing in the denominator, specifically no variable in the denominator. Thou shalt not take the square root of a negative number. Well, I have no radicals here, so I don't need to worry about having negatives under radicals. So when I have 1, no fractions, and 2, no square roots, meaning I'm not going to violate either of my 2 mathematical commandments, then my answer is all real numbers. Do the number sign. All real numbers, or if it wants it in interval notation, that is negative infinity to infinity. So when I have no fractions and no radicals, it has to have both. Then my answer is all real numbers or negative infinity to infinity.